In this example, we're also going to be having to think about reactions from chapter 14 because we are adding groups to the ring. So this one's even asking us to synthesize this molecule from benzene. So that is very much like the reactions and the questions that we saw in chapter 14. So we are going to have to make both of these bonds to the ring. So we are going to have to do a couple of electrophilic aromatic substitution reactions from chapter 14. One of them, we see the bromine, we're like, okay, we can definitely add that to the ring. We know the conditions for that, hopefully. For this alkyl group, we haven't really seen a way to add this alkyl group to the ring specifically. And especially with knowing that it's like an alkyl group, we're thinking it's probably a weak activator or some kind of activator anyways. This double bond might make it a little bit stronger than a normal alkyl group, but we do know it'll be an orthopara director. That's almost for sure. If we had a positive charge here, we could definitely bring those electrons over and stabilize it. So orthopara pathway definitely more favorable for this group. And so it's definitely an orthopara director. Bromine we've seen before, weak deactivator, also orthopara director. All of a sudden we have a problem because we have two orthopara directors and they're meta to one another. And so what that suggests is that one of these groups has to be added to the ring as something else. And when we had this situation before, we saw that we could add, instead of the alkyl group to the ring, we could add an acyl group, so having a carbonyl next to the ring. This is going to be a similar idea for this one. However, how are we going to have a carbonyl from this? Because normally we would just have a regular alkyl group, and we saw a way to take the carbonyl and basically burn it off and replace it with two H's, and then have an alkyl group, but we haven't seen a way to take a carbonyl and make it into this kind of compound, or have we? So let's think about the reactions that we just saw in this chapter. We saw a way of taking a carbonyl and making it into an alkene, and that's exactly what we need to do here. We are thinking it has to be a carbonyl because the bromine is meta to the group, and we saw that if we take this double bond and we do, or we take a carbonyl and we do a Wittig reaction, we can get this double bond. And so let's do the disconnection there. This is kind of opposite of what we were thinking in the previous video, in the previous example. We're kind of going the opposite direction here. But we could convert that double bond to a carbonyl. We just have to stop and think for a second because we're going backwards. We're thinking about taking an alkene to a carbonyl in the backwards direction. So in the forward direction, carbonyl to alkene. How do we convert a carbonyl to an alkene? The Wittig reaction. Then makes us still a little bit more complicated. So we know we're going to have to use the triphenylphosphine doubly bound to what? And so in this case, we see on the other side of the double bond, we're going to just have two H's here, and we can just leave it like this. We can put CH2 on the end if we want, but that CH2 will just be these two there. We could have just left it how we had it too. So that's the reagent we'd have to pair with this carbonyl. Now if we just rotated this, the carbonyl at the top and then this kind of going down, it really looks like that acyl group that we saw. And what we're going to have to do now is figure out, well, which group would be on the ring first. Now we have a meta director and the bromine is meta. So let's take off the bromine at this step because we're working backwards here. That's going to give us this molecule, and let's just rotate that carbonyl group. And then we could do the disconnection at the ring with a Friedel-Crafts acylation to get back to benzene and an acyl group, and then AlCl3 we're going to have to add as well. So when we're doing our synthesis from benzene, we're going to start with our benzene. We're going to do our Friedel-Crafts acylation with our acetyl chloride, our aluminum trichloride, to get this compound, then we're going to do our bromination. To get the bromine in that meta position. And then our last reaction is going to be one from chapter 15, where we're doing the Wittig reaction. And we don't have to say how we form that ylid for the purposes of this course, especially in a complex problem like this. Just putting the actual ylid itself is going to be enough with the carbonyl. And so then we're going to get this molecule here. And if we think about just rotating that, we're going to have the same thing because this bond can rotate. So that's going to be the same thing as this one. And notice that a lot of the times we are talking about just rotating that group. That could be a place to start if you're really stuck, maybe just trying to rotate that bond and draw it a different way. It could help to trigger something that is like, oh, well, this could kind of maybe be a carbonyl because we usually draw carbonyls right side up, that kind of thing. So that can be a trick too to help solving these problems, is just to do the rotation if they're kind of shown with a funny rotation. And this is one of the things that if we want to label, we have our Friedel-Crafts acylation reaction that we did from chapter 14, our bromination, also from chapter 14, and then our Wittig, which is new.